Okay, so I have, come on, there we go. I have f of x is equal to 4 minus x divided by 3x. And the problem says find the inverse and then state the domain and range of the function and its inverse. Okay, so I have the steps right over here on the left-hand side. The first step is the one that nobody should ever lose points doing, right? And that is changing f of x to y. So I go y equals 4 minus x over 3x. And the next one is another one that nobody should ever lose points on. It's just switch the x's and y's. Wherever you see an x, make it a y. And here we see a y, make it an x. So I have x is equal to 4 minus y over 3y. And this is called the implicit form of the inverse. It's not explicit, like, you know, when something is explicit, it's like super clear, you know, you're explicitly doing something, right? It's implicit because explicit is when we get the y all by itself. We don't have the y all by itself yet, so this is just the implicit form. So now I have to solve for y. That's my third step here. Well, I'm going to multiply both sides of this by 3y, because I want to get rid of my denominator. So that gives me on the left-hand side 3xy, and on the right-hand side 4 minus y. What I want to do next is I want to get all of the y's, because I'm trying to solve for y. I want to get all of my y's on one side of the equation and everything that's not a y on the other side of the equation. Yes?
So would you do plus y and then plus y on the other side and it'd be y squared?
Okay, now it won't be y squared. Oh. I'm just gonna add y here, and I'm gonna add y here, and then I'm gonna have on the left-hand side 3xy plus y is equal to 4.
Can it be 2y?
No, because I got that x in there that's really bugging me. Right? I don't have like terms here, do I? Right? So I'm stuck with this 3xy. And this is kind of one of these little algebra tricks that that as you do it a few times, you'll get used to it. But I will be honest with you and tell you I had to do this about 15 times before I kind of saw it, and then it just kind of hit me. That's why I say get all the y's on one side, everything that doesn't have a y on the other side. And the trick is this. I'm going to factor a y out of my two terms of this binomial here. It means I'm going to go y times 3x plus 1 is equal to 4. Because once I do that, I'm in pretty good shape. Because now I can divide both sides of this equation by 3x plus 1.
Oh.
And what do I have all by itself on the left-hand side? Y. So y equals 4 divided by 3x plus 1. And then my final step, which, again, nobody's allowed to miss any points on this step, is to change my y into f minus 1 of x is equal to 4 over 3x plus 1.
Oh. Okay.
So I've gone from function, just followed the steps, did the little algebra trick, to inverse. Now, domain and range. Okay. I'm going to go back to my function. I'm going to start with my function. What's the domain of my function? Oh, let's go to the magic bowl here. Charisse, can you tell me the domain of the function? What?
Y. I didn't.
Okay, domain, 2 questions. Question number 1, variable in denominator. Yes. Question number 2, variable under a radical sign with an even index. No. So all I'm concerned about is variable in the denominator. And I have to make sure that the variable in my denominator doesn't make my denominator 0. So what can x not be equal to? 0.
Wait, why?
Because if x is equal to 0, then it makes my denominator 0.
That's bad.
So that is my domain of my function. Okay, everybody all right with that? Okay, let's look at the inverse here for a minute. So, 2 questions. Variable in the denominator? Yes. Variable under an even index radical sign? No radical signs. No. So I have to make sure that my denominator doesn't equal 0. So if I want to know how to do that, I'm going to say, okay, what if I said 3x plus 1 equal to 0? That'll tell me the value that I can't have for x.
Wait,
So,
what?
yeah,
I don't know.
I-
Can you say that again?
I cannot have my denominator equal to 0. So I'm going to set my denominator equal to 0, which tells me what values of x I cannot have. So I have 3x is equal to -1, x is equal to -1/3. So my domain of my inverse is that x cannot be equal to -1/3. We're okay with that? Okay. Yes? Very good.
So you just have to write that?
That's right. Yes, Francesca.
So then you would write that with like a parentheses, -1/3, comma, infinity.
Well, if I wanted to write this in interval notation, I would write it like this. I would go negative infinity all the way to -1/3. Because I can go all the way from negative infinity all the way to -1/3. And then a parentheses. Because I can't include 1/3, -1/3. But then I can unite that with going from -1/3, not including it, all the way to infinity. So that would be how I would write that in interval notation.
What about the 0? You don't care about it? The range, the domain? You don't care about that?
Well, so here's the question. The domain of my inverse here is x cannot be equal to -1/3. That's the domain of my inverse. And we know that with your function and with your inverse, all we're doing is switching our x and y values, right? So if my domain of my inverse is x cannot be equal to -1/3, what is the range of my original function? The range of the function is that y cannot be equal to -1/3, because the range of the function is the same as the domain of the inverse. Right? The x's in the function, the y's in the function are the same as the x's in the inverse. The x's in the function are the same as the y's in the inverse, yes.
So then, how would you write the interval notation?
Same way. Same way. Same way. Write it the exact same way. What is then the range of the inverse? What's the range of the inverse? Lila.
I think wait, you just said it was -1/3, but.
The domain of the inverse is that x cannot be equal to -1/3. the range of the inverse not sure. The range of the inverse is the domain of the original function. The domain of the original function, x cannot be equal to 0. So the range of the inverse would be y cannot be equal to 0.